Okay, good morning. Welcome to
SuperMath number 33.
SuperMath33. We're going to just go through an example from the book on angle-angle similarity. And you did such a good job on the last one, I thought we would just do this one live and see how it worked. So the chapter is about angle-angle similarity. And it says find BC and DC. BC and DC, given that AD is 3, BD is 4, and AB is 5. Okay, and I got a couple of right angles in there too.
So, this and this we're supposed to find.
Right.
Well, if they were similar, we can find where all these sides match up.
Okay, if what was similar?
If this triangle and this triangle are similar.
Okay.
So, it looks like the 3 would match up with the 4. This goes here.
Okay.
The 5 is the long side. And then the 4 would be this side.
Alright, so show me which triangles you think are similar. Write them out.
So, triangle ABD and triangle BCD.
Alright, so triangle ABD you think is going to be similar to triangle BABD. Might be similar to BCD. So D is the 90-degree angle in each one.
Yeah.
Okay, and therefore what sides correspond to each other?
So I was thinking the 3 corresponds to the 4.
Alright.
The 5 is the long side. And the 4 would correspond to that side.
Okay, well let's look and show me. The 5 is opposite what angle?
5 is opposite the 90-degree angle. This one.
Okay.
So that, this one is 5.
Okay. So it's important, really important to make sure. You said 5 was opposite this side, but the 5 is opposite the right angle. This side is opposite this angle here. Okay.
So,
now you drew the triangles right. AB corresponds to BC. Just make sure when you draw them out.
So the 5 actually goes to here.
5 goes to there. So I'll erase your little mark from the 4.
So it means the 5 and 4 are switched.
Okay.
So.
Alright, so that's if they were similar. So now you just have to use angle-angle similarity to show that they're similar.
Well, we already have these two angles that are the same.
Okay.
We do have a big right triangle that we haven't used yet.
Ah, interesting.
So this angle plus this angle is 90.
Okay.
So, but can we say anything about that?
Well, that's a good thing. This angle plus this angle is 90. So why don't you label that with 1 tick mark and that with 2 tick marks? That and that.
And
Right.
I know this plus this is 90. That
part. Okay.
But this is actually, it's just this one.
Why?
Because it's the part of the 90 that's missing.
Right, there you go. Okay.
So we have this angle and that angle are similar to that angle and this angle.
Okay, good. So now how does that help us solve?
Well, all 3 angles are the same because you have the two same values.
Mm-hmm.
So,
all right. So what are we going to use for our similarity now?
Well, if 3 goes to 4, so you're multiplying everything by 4/3. So we need to multiply 4 times 4/3, which would be 16/3, or 5 1/3.
Alright, it's okay to leave it at 16/3.
And then 5 times 4/3 would be 20/3,
Okay.
which is pretty close to 7.
It's pretty close to 7. Yeah. Is it bigger than 7 or less than 7?
It's a little less because 7 is 21/3.
Okay. But it's okay to leave it as 16/3 and 20/3 because that's what it is. Right?
Yep.
Okay. Very good job. I like your approach. If they were similar, we would have those two triangles that are the same. You got a little mixed up on the sides. You just have to be careful to make sure you match the sides that are opposite the same angle. And then find the proportions. Very good. Good working through that. That's a very, very challenging angle similarity problem.